All right. Hello, everybody. Welcome to our live demo of the DataRobot demand planning app for SAP. Good morning, good afternoon, good almost afternoon, wherever you might be. We appreciate you taking the time to join us this morning. Today, Anthony is going to be providing you with a quick live demo of this new awesome app that we have available. But quickly before that, I just have a couple of quick housekeeping items to go through with you. First, this will be recorded. That is great because then we will share it with you and you can share it with all of your friends or rewatch it or go back to those key pieces where you continue to want to see more or dive deeper. That will be shared following this call via email, so keep a lookout for that. Also, questions will be answered in the Q&A chat. There is a Q&A button down at the bottom. Utilize that, ask all your questions. We have Anthony here doing the demo, and one of our technical experts just be answering questions. Go technical, ask all the things. We will be happy to provide answers for those. Anything that we may need to dive deeper into, we will answer following or get back in touch with you on that. That said, without further ado or me talking, I'm going to hand this over to Anthony for the demo of our demand planning app. Anthony, over to you.
Perfect. Thank you, Rebecca. So yeah, welcome to this demonstration of how DataRobot supply chain AI app suite can enhance supply chain operations and planning within SAP's Integrated Business Planning tool, or IBP. So ultimately, we're looking to help organizations make more accurate data-driven decisions so you can ultimately optimize your inventory and reduce inefficiencies. So we're going to start here with Sarah. So Sarah's a demand planner at a national retail chain. She's responsible for keeping the right products stocked while minimizing excess inventory. She's got tens of thousands of SKUs. Every one of them has complex sales patterns, and it's influenced by seasonality, promotions, and regional demand. So every week, she reviews a 12-week rolling forecast. But she's found that these traditional forecasting methods she's used in the past, they often make it challenging to account for things like short-term demand shifts. And so that leads to overstocks and consequently markdowns and lost margins, as well as stockouts, so lost sales and unhappy customers. So you've got promotions, you've got regional and customer differences as well, adding further complexity. And so it can be difficult to get a precise store level, product level forecast. So Sarah relies a lot on her own deep expertise and a lot of manual work to try to review the SKUs and arrive at a forecast that everybody agrees with. But even with all the effort that she has, the results are often far from what's required. So with DataRobot's AI-powered forecasting, she's able to separate true demand from those promotional spikes, and she can adapt her forecast at a granular level, accounting for those things like seasonality, location differences, historical trends. And ultimately, by augmenting her expertise with these AI-driven insights, she can refine the inventory plans more efficiently and ensure that the right products are available at the right time, reducing those markdowns and those stockouts. So we're going to switch to the demo now. Now, SAP IBP provides planners with a very strong foundation, but there's still substantial opportunity to be able to enhance that to make sure that you're getting the highest levels of accuracy. With the demand planning app that we've created, we've made sure that we've got seamless integration. So you can continue to leverage all of your existing workflows and your tools. And so you can take the AI-driven forecast that we produce and you can consume that in Excel. So here we're looking at the Excel IBP plugin, which is one of the most common interfaces that you can use. We've got the IBP ribbon up the top, and we're using one of the common starting templates from SAP, or you could be using IBP's web interface. So again, here we're looking at a similar kind of view. This is a planner workspace. You could be looking at a dashboard, you could be looking at an analytics story. It's all based on the same kind of data. But what we're going to do is we're going to start in Excel. And we're going to use the IBP plugin here to use the actuals quantity data here, and we're going to forecast that into the future. So we've got a couple of key figures here. One is the actuals quantity, which could be sourced from, let's say, your SAP ERP, and the other one is the DataRobot external forecast. So this is the key figure that we're going to use to report back the predictions that we generate externally and bring them into this native interface. Now, your situation could be, of course, a little bit different. You might have a different template, or it could be that actually you're incorporating a lot more information in there in order to come up with your consensus demand plan. So here, for example, as well as your external forecast and your actuals, perhaps you're looking at your sales forecast quantity that you've either entered in that manually or you brought that in from another system. So you can still continue on with that process, leverage what DataRobot has been providing, and ultimately come up with your consensus demand plan quantity. Now, we're going to jump into DataRobot here. And the first place we're going to start at is here where we have a job that is going to execute that whole process. Now, I'm going to kick that off so it runs in the background. Now, you can run it on demand like I've just done, or you could be scheduling it as well. And the app actually is very flexible. What we're running here is this pattern where we're leveraging the Python APIs to connect directly to IBP. And so here we're able to pull in the information that we need. So the particular slice of the data that we want to forecast, we're able to push it back into the same area, including the forward time periods that we're forecasting for. And we can also be calling IBP in real time if we want to. So there's a lot of different combinations we can leverage here. We can also leverage BTP. So if we want to, we can be looking at things like integration suite with cloud integration. That can be following through into DataSphere. We can use our native SAP DataSphere connector to read that and then write that back directly into DataSphere, and that gets transferred back into IBP. We can also leverage the integration through cloud integration to be able to trigger off forecast directly from within the IBP interface, if that's the approach that we want to do. So we do have flexibility in how we're doing that. Now, if we come back to DataRobot, we're going to start off here with the use case. And this is the heart of the solution. It's a single container to be able to hold all kinds of related assets. And we can see a number of different related assets here. This is the full view, so we're seeing everything at once. But actually, we can see on this left-hand side, we've got different data assets, experiments, and notebooks and code spaces if you're more technically inclined. And you can also see here, we've got vector databases and playgrounds. Now, we're not going to go into that in more detail here, but DataRobot as a integrated predictive AI and generative AI platform also makes sure that there is a seamless collection of all of those assets in one place. And that's in the use case. So let's take a look at the data set that was created. And we can see that it's quite a simple data set here. We're focused on a limited set of features here. We've got a single customer ID, but we've got multiple location IDs and product IDs, as well as the actuals quantity and the period. So we're looking here at a weekly time period. And in actual fact, we could add on additional factors out of here as well. So we could bring on other potential influencing factors like perhaps climate or macroeconomic statistics. That could be incorporated here so that all of those factors could be taken into account. Like we can scale to hundreds or thousands of features if that's something that's required inside of your forecast. Now, for now, we're going to focus on the experiments. And we've run one experiment here. So what we're seeing here is the result of DataRobot's comprehensive automated process. It's evaluated many, many different approaches to find that optimal model. So this is a super critical part of the process. We could spend hours just going through all of the capabilities here, but I'll just skim over some of the top level details here. We have a number of features that have been created from here. So if we look at the original set that we've got here, we've got actuals quantity as a single field. What we've got in this experiment is we've actually automatically generated a number of other features from there. So we can see that actuals quantity has been expanded out, and now we have things like the 12-week average, the 12-week max. That has been done by DataRobot in the background. it's also indicating to us the relative importance of each of those in determining the actual target. Now, we can also have a look at a number of blueprints that are available. So as part of the experimentation process, we can draw upon a very large number of open source models and proprietary models that DataRobot has within its library. And those can be used to determine what is the right approach to solving the problem. Now, if we click into some of these, you'll see that we can document the steps that are involved, and you can go through that in more detail to see what this particular blueprint uses. We can also look at things like the experiment insight. So as we're running multiple models and comparing them, we might want to look at things like the speed versus the accuracy and think about what is the trade-off that we want to have there. But for now, let's focus on the optimal model. So this one down here has been chosen and it's been prepared for deployment. Notice that we've got a number of other ones in here that have been run based on different blueprints. But as we click on this one here, then there's a lot more detail that we can see for this particular model. So it is by no means a black box. Some of the things that we can do here is we can have a look at the explanations. So if we click on something like the feature impact, then we can see in this instance, we have a limited set of features. So actually the product ID itself, the location ID are dominating in terms of actually coming up with the target. But we can also see that there are other things here. The derived 12-week mean is the next most important feature. Then we've got the naive latest value. So if we start to bring into the forecast a lot of other factors, then we'll be able to see for each of these models, which are those ones that are the most important. Now, we can also have a look at other areas. We can look at individual prediction explanations if we want, and we can get much more detailed with coefficients and distributions. But we can now click on this as well and look at things like lift charts and other ways to evaluate the performance. So you can look at the metric scores, how the accuracy goes over time, how stable it is, and plenty of other ways of evaluating what the model is performing at. We can also see, again, the blueprint that has been used in this particular model. If we need to, we can dig deeper into the log and see how the execution has been done and get information about the model. So how large is the model? How long does it take to run predictions? And how much RAM does it take? So all of this is part of the platform and it's all managed for you. Now, one of the things that we want to do is we want to come across to the console. So in the console, we're able to look at all of the deployments that we have here. And actually, we've got 73 deployments, but I've filtered that just to look at the one that we're particularly interested in. But here at a glance, you're able to look across all of those deployments and see how many predictions you've been triggering, what's the overall service health or drift or accuracy across all of those. I'll dig into this particular deployment here, and we can see that in this first overview screen, we've got the key information here. We've got information about, let's say, the target that we've defined, the type of the model, the features that have been incorporated, and we also have full traceability back to where it came from. So here we know that it's come from a particular model that's been registered. That model is sitting in a use case. It was generated by a particular experiment and it was built off particular training data. So we could click on any of those things and that'll take us back to those objects. So we're able to move easily back and forth between all of those. We also have a full traceability under governance. So if we had replaced this deployment over time, we find new models, then that will start to build and we'll see who has created or updated some of those deployments. One of the other things is that we can have a look at the really detailed monitoring capabilities. So this is an MLOps dashboard that you can adjust for different time periods, but we can have a look here at the service health where we've got almost 20,000 predictions. Those have been submitted through 32 individual requests. The average response time is 775 milliseconds. So there's a lot of information we can see to get a good view of the usage and the health of the deployment. We can also look at things like data drift. So if the distribution of the data in what we're scoring is fundamentally different from what is being trained, then we're able to try to identify that and dig a little bit deeper into why that might be the case. And if we're If we're drifting too much, it might be a good indication that we should be retraining the model. We can, of course, also look at accuracy. So here we've got a number of different metrics that you could use to be able to detect any kind of accuracy changes. We've actually got one here where we've just kind of simulated quite a drastic jump there. So we can see that the error rate was fairly stable, and then all of a sudden it started jumping up. So you can monitor this, you can be alerted of this, and you can make sure that over time, you're ensuring that that accuracy will remain. You also have the ability to look at challenger models. So in the background, even if you've picked the one that you felt was best at the time, you can continue on and compare that with other challenger models. You can export these deployments and run them outside of DataRobot. You can call the API. We've got a very extensive API that can be used to create all of these objects. And in fact, the app automates the creation of all of these objects as part of its template. And you can, of course, come into here and you can have a look at all of the additional settings, but we won't go into too much more detail there. This is just a quick demo. So what we'll do now is we'll come back to Excel and we'll refresh this, and hopefully, if everything's worked okay, what we can see now is that we have these predicted values, the forecast values for the next 12 weeks, have now been populated for all of those combinations that we've now predicted. Okay, so let's recap. Before DataRobot, Sarah had to rely on suboptimal forecasts, and it required significant effort to try to improve results. And she had to use her expertise to balance the overstock and stockout conditions. So now with SAP IBP and DataRobot, she's able to leverage these AI-powered forecasts, and she can get insights and handle complex sales patterns at scale. She can distinguish true demand from those promotional spikes, and she can adapt the forecast store by store or SKU by SKU. DataRobot's approach allows for the incorporation of external data to be able to accommodate for the influence of broader factors. It allows for automated feature engineering to enhance productivity. We've got sophisticated proprietary and open source time series models to help optimize those results. We've got deep insights, including feature impact analysis, ultimately to provide that transparency. And we've got continuous monitoring. So we can look at health and accuracy and drift. We can use our challenger models, and that can give you the confidence that you need to know that your model is continuing to deliver the performance levels. So ultimately, this leads to improving accuracy, reducing markdowns and stockouts, and ensuring that the right products are available at the right time. So hopefully we can work with you. We can provide a bit more information. We can tailor this solution to your exact scenario. And yeah, we would love to talk some more.
Thank you, Anthony, for the demo. I greatly appreciate the time. Thank you to everybody who has joined today. If you do walk away and have questions, please feel free to reach out to the DataRobot team. In your email, expect, like I mentioned at the beginning, a recording of this demo so you can go back and see again, as well as links to learn more about our solutions and in conjunction with SAP, as well as links to be able to request your own demo and see an even deeper detail. Again, thank you for the time today, and have a good rest of your week. Bye, everybody.
Thanks a lot.